draw a triangle, we know tangent of x is 3/4 and that we are in quadrant 3. So if you draw a triangle in quadrant 3, we've talked about how your x is from the center here. Tangent is opposite over adjacent. But if you're in quadrant 3, what would have to be true about both of those numbers?
Negative.
They're both negative because you go back 4 and down 3. Then if you do Pythagorean theorem, -3 squared plus -4 squared equals c squared. You get the hypotenuse to be 5. So then you're asked to find secant. Secant is hypotenuse over adjacent. So you get -5/4. Number 17. Sine 225. This is a unit circle question. What quadrant is 225 in? Reference angle. So 225 minus 180 is?
45.
Okay, sine of 45 degrees.
Square root of 2 over 2.
And in quadrant 3, is sine positive or negative?
Negative.
Negative radical 2 over 2 is your answer. 18 is another unit circle question. 5 pi over 6 is in what quadrant?
2.
Reference angle is pi over 6, or that's the same as 30 degrees. Okay, in quadrant 2, secant, that's reciprocal of cosine. Is cosine positive or negative?
Quadrant 2 is negative.
Okay, cosine of 30 is radical 3 over 2, so secant would flip it, so 2 over radical 3, or -2 radical 3 over 3. Number 19, we have 4 cosine -3 pi over 4. Okay, when we had negative angles, typically what we did is got the coterminal angle to make it positive. So if it was in degrees, we would add 360. If it's in radians, what do we add? So 3 pi over 4 plus 2 pi is 5 pi over 4. 5 pi over 4, what quadrant? Reference angle is pi over 4, which is the same as 45 degrees. So we have 4 times. In quadrant 3, is cosine positive or negative? Negative. What is the cosine of 45?
Radical 3 over 2.
We get -2 radical 2. Is that okay? Number 20. Cosine of 5 pi over 12. This is not an angle we had in a unit circle. So it might be easier to think about in degree form. So if you want to multiply by pi, or 180 over pi, you get the cosine 5 times 180 divided by 12 is, thank you, 75 degrees. So we don't know that one, but I said exact value, so that means you can't give me a decimal. We have to think about our formulas. So are there 2 angles that we know that would add or subtract?
45 and 30.
Okay, then look at your flip chart or your formula sheet. Cosine of A plus B. That's cosine A times cosine B minus sine A sine B. And then we evaluate. So So the cosine of 45 is radical 2 over 2. Cosine of 30 is radical 3 over 2. Minus sine of 45, radical 2 over 2. Sine of 30, radical 1 over 2, or 1/2. You guys know where I'm getting all of those from my hand trick?
Yeah.
So if we multiply radical 2 times radical 3 is radical 6, over 2 times 2 is 4, minus radical 2 times 1 is radical 2 over 4. Let's go to 22 then. Okay, so I said to write it in terms of sine and cosine. So secant is
1 over cosine.
minus tangent is
Sine over cosine.
times sine. This is like a sine over 1. So we have 1 over cosine. Minus, if you multiply those, that gives you sine times sine is sine squared x over cosine x. Because these have the same denominator, we can put them together in one big fraction.
And then 1 minus sine squared x is equal to cosine squared x. And so since it's divided by cosine x, it gets rid of 1 of us, so then we just have 1 cosine x.
Is that okay? We had 23, everything except 24 on this page, sorry. Okay. Let's change the sines and cosines. If you don't recognize a formula immediately, then that's kind of always where I go to. So tangent
Sine over cosine. Cotangent is cosine over sine. And then we could put cosine x as the cosine x over 1.
So if you multiply this first one, you get sine x cosine x over the denominator is also sine x cosine x. This one, you get sine x cosine x over 1 times cosine x is cosine x. What happens in this first fraction?
Everything cancels out.
And if
So we
everything
get 1.
cancels, you get a 1. Minus, in the second one, cosine drops, so we get a sine. If it were 1 minus sine squared, that's equal to something, but 1 minus sine is not. So that's our final answer. So now we have the proof. So we start by boxing in usually the easier side. Which side looks easier?
The right side.
Box that in. We're not going to touch it. That's our goal. So we work with the left. If we want to add or subtract fractions, what do they have to have? This one has 1 minus cosine on the denominator. So to look like the other one, it needs 1 plus cosine. This one has 1 plus cosine, so it needs 1 minus cosine. So then we FOIL. So we get 1 plus cosine x and plus cosine x plus 2 cosine x plus cosine times cosine is cosine squared x. Denominator we get 1 plus cosine x and minus cosine x drop. Minus cosine squared x. Minus this one, you get 1 minus cosine, so minus 2 cosine x. And negative cosine times negative cosine is positive cosine squared. Denominator 1 minus cosine squared x. Now we have the same denominator, so we can put them together. I'm going to distribute this negative through, and then combine my terms. So 1 and negative 1 drop. 2 cosine plus 2 cosine is a 4 cosine. Cosine squared and negative cosine squared drop. Over 1 minus cosine squared x. What is 1 minus cosine squared equal to?
Sine squared.
You might see it from here. If you don't recognize, sine squared is the same as sine times sine. So we have a 4. What's cosine divided by sine?
Cotangent.
And this is just like a 1 over sine, which is, and that's what we want. Remember, if you get stuck, so maybe you got to the 4 cosine x over sine squared and you didn't know where to go, you also have the option of going and working the other side and trying to get it to the same point. And you'd probably be able to get there pretty quickly. Is that okay? Then we got into graphing, which was pretty easy when we did it, but it's been a while, so you might need a refresher. So the first one, amplitude. Where do you look for the amplitude?
Whatever trigonometric is.
Right. Amplitude is just that coefficient. So our amplitude is 3. Period. Sine, cosine, secant, cosecant all have a normal period of 2 pi. Tangent and cotangent are different. What's their normal period? Pi. So we do 2 pi and then you divide by the coefficient of x. So this is 2 pi over 2, which is pi. Then we did our count by. And count by is whatever you get for your period divided by 4 for the 4 quadrants. Then we did interval. Remember, everything except tangent and cotangent we just set up between 0 and 2 pi. And we're solving for x. So if we add our pi over 3, divide by 2. And we get from pi over 6 to 7 pi over 6. So now we do our graph. So my first point will occur at pi over 6. I asked for 1 period, so we need 4 additional points. And how do we get those points? Yeah, we're adding the pi over 4, the count pi over time. Try to space these evenly. So pi over 6 plus pi over 4. If you're confused with that, you can use a calculator. You do 1/6 plus 1/4. So pi over 6. So 5 pi over 12. And 8 pi over 12. So 2 pi over 3. And 11 pi over 12. And 7 pi over 6. And you'll notice the last one was where my interval ended. If I asked for a second period, what would you do? Yep, 4 more points. Amplitude is 3. So my high point would be positive 3. point would be negative 3. Right. Cosine normally starts at its high point. If you ever get confused on those, you could definitely just work it out. If you plug in a pi over 6, then you get 3 times the cosine of 0. Cosine of 0 is 1, 3 times 1 is 3. So you can plug them in if you have to. And it goes to 0, down to the low point, back to 0, and back up. When you draw them, nice smooth curve. Please don't make it a V shape, or it is like a wave. So it's just bouncing back and forth. Is that okay? All right, last one, number 27. All right, if you need to, you can flip this around. This is like a negative 3 tangent x with a minus 2 on the end. So what does the minus 2 do? And what does the negative in front do? So our amplitude, our coefficient, the amplitude is just the positive. Amplitude is positive 3. Period. Normal period for tangent and cotangent is just pi divided by the coefficient of x. So we just get pi. Count by is period divided by 4. Interval. What is our normal interval for tangent? Yes. Tangent is from negative pi over 2 to positive pi over 2. Cotangent is from 0 to pi. And then you put your argument or your angle in the middle. Alright, so if we graph this. So we're going down 2. So what we did is we went to negative 2. We just drew in a dashed line. So that's going to mark the center of this graph. And starting at negative pi over 2. If I add my count by, so plus pi over 4 is negative pi over 4. Plus pi over 4 is 0. Plus pi over 4 is positive pi over 4. Plus pi over 4 is pi over 2. Our amplitude is 3. So we're going to go 3 above, which would take you to positive 1. Or 3 below, which takes us to negative 5. Okay, we picked this interval for tangent for a reason. Both ends are vertical asymptotes. And the center is 0, but our 0 mark is down here at the negative 2. Okay, tangent is normally increasing. Starts off negative and becomes positive, but because I'm flipping it, this one will be decreasing. So at negative pi over 4, we're going to start 3 above. Positive pi over 4, we're doing the 3 below. Okay. Anything else you want